All right, looks like we're live. Hello, everyone, and welcome to another Zozin session. How about that? I bet you didn't expect that shit to happen yet again. It happens every time. Okay, so let's make a little bit of an announcement and start coding, I suppose. I really like this debated thingy. Okay, so red circle, live on Twitch, and what's the topic of today's session? The topic of today's session is searching for a faster assembly for our Porth programming language. Right, so I'm gonna give the link to the Twitch channel, so it's gonna be twitch.tv/tsoding, and I'm gonna ping everyone who's interested in being pinged. There we go. Let's get started. So, all right, and if we go into the Porth, right, so you can find the source code of this language in the description if you're watching on YouTube, and if you're watching live, you can find this thing in here. Right, so, and let's take a look at what we've done. So I've been working on Porth off screen, right, but I primarily was working on basically rewriting Porth from Python in itself, and it's almost done actually. So Porth already can compile itself, it's self-hosted, and on top of that it can finally type check itself. So I ported the type checking. So there's some unfinished parts of the type checking, specifically reports, right, different reports. I just didn't implement them, so if there is a particular type error, it will just say to do implement that report, but it basically reports that anyways. So let's take a look. So maybe I need to fetch the latest things. Let's see how many changes I've made. Git merge origin master, right, so, and let's go ahead and compile the entire thing. So far you can't really, the Porth can't compile itself, but we have porth.py, so when we can use that to compile the Porth. So you may notice that the slowest step in the entire process is actually NASM. And that's kind of basically today's topic, right? So I don't know what causes that. Maybe we're generating too much garbage that NASM is incapable of handling, but I don't think we're generating that much, right? And to be fair, I don't see any reason for NASM to be this slow, right? We can take a look at the size of this file. So it generated like almost a megabyte of assembly, and to be fair, like, I don't know, so we're not doing anything super complicated in my opinion. So maybe maybe I don't know something, but here is the assembly that we're generating. We have a lot of labels and stuff like that, so we can look into why exactly NASM is so slow, but I decided maybe we can just replace NASM with something else. We have a couple of other options, right? So NASM, by the way, maybe I'm gonna give the link to the NASM compiler. Right, NASM compiler. So here's the NASM, the assembler we use. And I have a couple of ideas, a couple of candidates to try. So I wanted to try Phasm. All right, so it's a flat assembly. So we can find this thing in here. So I'm gonna copy paste that in the chat for people who's watching live, and for people who's watching on YouTube, I'm gonna put it in the description. Right, so here is the thing, and I also want to try the GAS, which is a GNU assembler. I wonder if the GAS has like an official website. Apparently the official website is the bin utils, which is fair enough, sure. GAS, and we're gonna try this thing. So I don't really want to go into GAS because it's using AT&T dialect of assembly, which I absolutely despise, because I never learned how to use it. So, but maybe GAS has a mode where it uses the Intel assembly. I don't know, maybe something like that. Maybe there is a flag for that. We'll see. So, and to be fair, also keep in mind that these assemblers are basically a temporary solution. Right, so I just keep them so I don't have to think about generating actual ELF for now while I'm working on the language. And once I'm done with the primary stuff that I want to make first, I will implement the actual generation of like ELF, right, and get rid of the assembler dependency. There will be no like dependencies on assembler in Porth, right? So there will be no dependencies on assembler. All right, So let's take a look. And by the way, so here we have porth, which is native. So this is basically a native porth. You can take a look at this file. So as you can see, it's a 64-bit executable, and it's statically typed. The cool thing about porth is that it can compile itself. You can just basically feed porth.porth into porth. It will take some time, so, and then it will generate assembly. You may notice a very interesting thing. Porth.porth is slower than porth.py. It is slower. And there is a very good reason for that. We are doing absolutely nothing to be fast. Absolutely nothing. And you won't believe to which extent we do absolutely nothing to be fast. We're generating absolutely crappy assembly that does a lot of unoptimal reads and writes into the memory. We're not optimizing any of that. The modern C++ compilers try to optimize the reads and write into the memory. We just like do whatever you say, it will just do that in the most unoptimal way, right? Furthermore, we're not using any data structures, any fast data structures. We're not using hash tables. We're using linear arrays to search for the names, right? Linear arrays to search for the names. And on top of that, there is a lot of other like questionable decisions that I made. And I did all of that because I didn't care about the performance right now, because I need to implement the features first. Right, so I want to have a working porth.porth implementation, and then we can start working on optimization. So we're going to nail down all of these like unoptimal decisions that I made and make it faster. So, which actually does not really go into favor of Python, right? So to be slower than Python, you have to go to a huge extent. You have to intentionally make everything to be faster, and only then you may become slower than Python. So, okay. So, but for now, it is what it is. We're gonna have a separate stream where we're gonna do optimizations with the compiler. But for now, we're gonna use it as a slower compiler. Alrighty. So, did I forget anything? I hope I did not. I did not. Okay. So, what we're going to start with, I think we're going to start with just writing a hello world in Nasm, right? And then try to port that hello world in Phasm, just to get the gist of how to use Phasm. Right, so first thing I want to do, I want to try to get the gist of how to use this assembler. And once I get the gist of how to use it, I may start to write a generator, a custom generator for that specific assembler. Jeff Vaz, thank you so much for 7 months of Twitch Prime subscription. Thank you, thank you, thank you. And welcome to our epic Porth Club. How about that? Bitch, expect that shit. All right, so let's go. So this is going to be a porth. Right, in porth, there is a very interesting procedure, proc generate. There we go. So here is the procedure. Generate Nasm Linux x86-64, and I have no idea what it is. So it takes a single pointer, right? And what that pointer is, apparently it's a file path. Okay, so it basically takes a file path of like assembler file to generate and just generates that assembler file. So what it does, it basically goes through the intermediate representation of our language. So the first thing that happens when we compile something, we're generating a sequence of instructions in our intermediate representation, and then we give those sequence of instructions to the generator. And generator basically goes through them, and if it sees the instruction push integer, it generates this sequence of instruction. If it sees something like push local memory, it generates a different sequence of instructions, and so on and so forth. And for each instruction in intermediate representation, it just generates assembly. So the same thing that we did in Python, remember, I just rewrote that in porth itself, right? So it's literally the same thing. You can even take a look at porth.py. So, and in porth.py there is a generate Nasm, and it's literally the same thing. So you have a huge switch case, and for intermediate representation, we just generate these assembly instructions. I literally rewrote that in porth itself, right? Because I'm trying to hit the self-hosted compiler. Right, so this is a generator specifically for x86-64 Linux Nasm, right? So that's why it's called generate Nasm Linux x86-64. So we're gonna have like different kinds of generators. So we're probably gonna have something like generate Phasm Linux x86-64, right? And it's also gonna take the file path, right? So for now, we can basically say that this thing is not implemented here. I'm going to print here to the standard error. Here, by the way, is an intrinsic of our language. What it does, it expands to a string that contains the file name, colon, the line, and the column of the current position of this thing. So you can use that for logging. Right, so you can say something like here, you will print it in here, then you put column and say to do, generate Phasm is not implemented, right, is not implemented. And then we can exit with non-zero exit code. I can actually demonstrate you how that works. So it's going to be here, porth, right, so let's include the standard library, std porth. Right, if you do something like hello world, right, so here is hello world puts, and I'm gonna just try to do porth simulate here dot porth. Right, as you can see, it just says hello world, right, but on top of that, I wanna do a new line in here. All right, so if you put here instead of hello world, it will print you here.porth 3.1, and 3 is the line on which it was generated, and 1 is the column, right? So this is the first column. And you can use this kind of stuff for to-dos. To do, not implemented, something like this. And if you try to do that, as you can see, it just generates this nice string, which you can use for, you know, for some logging. And I use it throughout the entire porth implementation, which is kind of convenient. So in here, when I call this function, I can just say that this function is not implemented and crash the entire application, right? So on top of that, we can have something like generate gas, Linux x86-64. We're going to accept the file path. And then we're going to say that this particular function is not implemented, right? So this is going to be gas. All right, so, and as far as I can understand, this entire thing is not going to compile whatsoever. If I try to compile this entire thing, it's not going to compile, because I have some unhandled data on the stack. You see, procedure said that it accepts a single pointer through a data stack, and it didn't say that it returns anything. Usually you put output parameters after the bike shader operator, but we didn't provide any bike shader operator, so this function is supposed to return nothing, right? So you are obligated to handle this file path somehow. But since this entire thing is not implemented, the only thing we can do here is just drop it, right? So in our compiler actually checks for these sort of situations, right? It checks whether you said that you're gonna handle something, but you didn't handle that, we check for that, right? And it tells you that, please handle that. And after that, it will successfully compile the entire thing. Right, there we go. So, and it generated a new compiler, right? So, but it right now generates it with under the file name output, right? You'll have to like specifically do something like output, rename output to porth, right? So there we go. And now we have a new compiler, which has like a new implementation. So basically I didn't even use Python version of this compiler at all, right? So I modified porth.porth and I used porth.porth to recompile itself to get a new version of the compiler. Right, so, and porth.porth has everything I need. It has all of the checks, it has all of the static typing and stuff like that. So, and at some point I'm gonna rewrite all of the Python code in porth, and we're gonna completely get rid of all of the scripts in, all of the Python scripts from the code base. So, sounds good, sounds Gucci, sounds Tamaguchi. All right. Okay. So what I want you to do, I want you to get the gist of the Phasm, right? So we're gonna start with Phasm. So before I can get the gist of the Phasm, I need a working hello world example in NASM, which you can port to different assemblies, right? So let's do something like hello asm, right? So here it is. Does anyone remember how to write a hello world in NASM? I don't quite remember. So I suppose first thing you need to do, you need to say that you're in 64 bits mode. Maybe you don't have to do that, maybe it is by default, but who fucking cares? Okay, so we have a couple of sections in here, right? So it's specifically in elf. There is a section called .text, and this is where you store the code of the application, right? So this is that. And there's another section called data, right? So this is the data section. And this is where we're gonna store the hello world string, if I understand correctly. Right, can we do something like hello and just say allocate hello world in here, right? So we probably have to provide the... To be fair, we're going to be using the write syscall, and write syscall doesn't care about the null termination. Okay, so let me try to compile the entire thing. So I'll have to generate F64 assembly. So maybe I'm gonna create a folder hello where I'm gonna keep all of that in here. Right, so and let's create a makefile. Right, let's create a makefile where we have hello.o and it depends on hello.asm, and I think it does nasm elf64 hello asm, right? Hopefully that will work for us. So I'm gonna do make, and it generated the O file, which is kind of cool. And if I try to do another thing, so after that we have to do hello, hello.o. We have to use the linker hello.o. I think it won't link properly because the linker expects the entry point _ start. Right, so we have to provide this entire thing somewhere. Sequin define, I hope I pronounced your nickname correctly. Thank you so much for tier 1 subscription. Thank you, and welcome to our epic Port Club. Alrighty. So let's do _start, right? And so that's probably it. So I'm gonna try to recompile the entire thing. And here's the interesting thing. I provided _start, but it still cannot find it because it's not an external symbol, right? It is not an external symbol, so we have to do something like global _start, and only then the _start is going to be visible, right? So it generated an actual executable, which you may try to run, and it will probably segfault, right? It will probably segfault. And the reason why it segfaults is because it starts execution somewhere here and continues execution and probably goes into the section data, but I'm not really sure. So are the section text and section data located in memory like near each other? Probably not. I would presume that Linux kernel would put them somewhere in different places or something like that, maybe. Right, so, but in any case, it just continues executing whatever garbage it has, and that garbage may instruct it to start touching the memory in inappropriate places, and as soon as you start touching the memory in inappropriate places, the kernel says, no, and kills you. Basically throwing a segfault, signal, right? So you're not allowed to touch memory in weird places. So, and the way you usually finish the execution of the program, you have to perform the exit syscall, right? You have to perform the exit syscall. So let's go and see how you do the syscall. Linux syscalls for x86 64. So I remember that it was somewhere in a Chromium. Yes, Chromium OS. So where is the exit syscall? Here it is, and its number is 60. So let's go ahead and quickly define something like exit, and this is going to be 60. And for the syscall, you're supposed to put the syscall number into the rex, right? So the first thing we have to do, we have to move exit into the rex. So this instructs the operating system that this is a 60 syscall. So the first argument is in RDI and it indicates the exit code, right? So we're going to do RDI 0, indicating that we want to exit with 0 code. And after that we say perform the syscall. So that should be enough, right? So let's actually try to recompile the entire thing. And now we have a hello world executable. And if I try to do hello, it finishes with a 0 exit code. The green sign finished indicates that whatever program I run from within Emacs exited with 0 exit code. Right, but as I already said, you can actually control that exit code. You can put whatever you want. You could put 69 in here, right? And if you recompile the entire thing, it still compiles. And if you run it, it says that compilation exited abnormally with the code as 69, exactly the code that we put in here. So pretty straightforward. We're gonna stick with the 0. Cool. So we have a working program that can exit successfully. right? It can exit successfully. But now we want to print hello world. Right, to print hello world, we need to use the write syscall, right? So let's take a look at where it is. So here it is, write syscall, and the number of that write syscall is 1. So let's actually do something like define write. So usually the convention is syscall is something like sys write. I think this is how you define these things, right? So it's like sys, capital sys, and then the name of the syscall in small letters. But I mean, it's just a convention. Who cares about conventions? Not me. I'm here to break all of the conventions. Move rex sys write. So the first argument of write is basically the file descriptor to which I'm actually writing everything, right? So RDI, and we're writing everything to standard output, and the standard output is basically 1, right? So std out, we might as well actually define std out somewhere here. Why not? Std out, this is going to be 1. Cool. So the second argument is the pointer to the buffer, right? So it's a pointer to the buffer, it's RSI, and the pointer to the buffer is this thing. So we can do something like move RSI, hello, there we go. So, and the last argument is the size of the buffer, and it's located in RDX. And the size of the buffer, well, we can actually hardcode it, right? We kind of know how many characters we have in here. We have 12 characters plus 13's one. We can actually hardcode that, but there is a better way, usually in assembly, just use the capabilities of assembly to calculate the distances between addresses or something like that. But we're gonna go with just 13. Right, and after that you just perform the syscall. Right, so as you can see here, we perform 2 syscalls. First one writes to the screen, and the second one writes to the exit. Right, if we try to compile this entire thing, it seems to be compiling, and if I try to do hello, there we go, here is hello, and that shit did not work, because I forgot that Nasm does not handle the escaped characters in here. So yeah, if I remember correctly, to actually use something like a new line, you have to do something like this, right? So that's how we do that. Even Porth supports escaped character. This is so lame. Nasm does not even support escaped characters in a string literals. But still, it takes so much time to compile 1 megabyte file. If you're not doing much, if you're not even, you know, handling escaped string characters, you better be fast at least. Like, you better be fucking fast. Jesus Christ. So considering the time it takes to compile our source code, it could have spent that time handling escaped characters, at least. That's what I'm trying to say. Alright, so anyway, so here's, we need to recompile the entire thing. So here it is, and then I'm gonna say hello, here is the hello world. How about that? How about that? How about that? How about that? Okay. So let me see. So the first thing we probably want to do, we want to take a look at Phasm. Do I even have Phasm in here? I do have Phasm, right? So let me go into the make file. Right, so this one is going to be oh boy. So let's actually rename this thing into maybe Nasm. So this is going to be just Nasm, and this is going to be Nasm, right? And the O is also going to be Nasm, right? There we go. So, and in here, hello Asm. Let's also call it Asm. I think it's a good idea. Right, so in here I'm just gonna do Nasm, and I'm gonna just delete the entire thing. So make -b, and here is hello Nasm. Cool. So now I want to copy paste hello Nasm to hello Asm. Phasm, I mean. Phasm.asm. There we go. Okay, so that was very interesting. Thank you, Emacs, very cool. So, and now I'm gonna simply maybe copy paste the entire thing. So in here, I'm going to replace Nasm with Phasm. Nasm, Phasm. And I suppose we're gonna start experimenting, right? So what if I try to compile it like this? I never used Phasm in my entire life, by the way, so this is gonna be basically me experimenting with this entire thing. Okay, it doesn't know about bits 64, right? So let's get rid of it. So I suppose this is how you comment. And apparently it doesn't have this sys exit, but maybe it does have some sort of like a preprocessor. Let's actually Google it up. Phasm Preprocessor, right? Let's find out. There is a Phasm Preprocessor. Cool. Basic preprocessing. Can you define things? So you can include things, but can you define? So there is a bunch of macros. Oh, this is actually pretty cool. So this looks like a very like powerful macro system or something like that. That's very interesting. Huh. Ooh, that is sexy. Holy shit. Okay. That is very, very interesting. Directive common, directive reverse, and stuff like that. A macro with one argument. Simple macros without any arguments. I remember there was like a very simple thing. Macro A1, right? Okay. Macro A2, and it just, ooh, this is cool. So you define macro A, which expands to 1, then you have another one A that expands to 2 and A, and then you can kind of like generate this sequence. Huh. So can I do shit like, you know, macro? Maybe I need to have like a Phasm mode, but I don't have a Phasm mode. This thing and just like 60, right? And for all of this one is gonna be just a macro, like this. Can I do shit like that? This is actually very cool. Right, so let me see. Okay, so it actually advanced the compilation, right? So now it doesn't know about section. So I'm wondering if I can have like a Phasm highlighting. That would be kind of cool. So Phasm. It doesn't have a Phasm. Okay. What about Emacs Phasm? So maybe Melpa doesn't have that. So, okay, there is something on the official... it's available from Melpa, so it is not. I think they removed it. Yeah, they straight up removed it. Right. They straight up removed it because I checked it. Maybe I actually checked that very, like, uncarefully. Let me see. So if I do Phasm, yeah, so I think they removed it because nobody used that shit. Anyway, okay, so it doesn't know how to split things by sections, right? So Phasm section, how do I define a section? Flat assembly.data. Oh, okay, so that looks like, yeah, so we have a data, you have .code, look at that. But this looks like more of a Windows thing, right? So, but we are in Linux. So instead of code, we're probably gonna have like .text. If I try to compile this entire thing, processed text illegal instruction. That is very weird. Oh, okay, so this is incorrect. I'm probably looking at somebody's incorrect code, right? So that's basically what's going on. All right, so possible without using macros. Okay, so section.data, and I wonder if I can just say section like this without any additional stuff. Probably not. Okay, I have an idea. What if I just Google Phasm hello world? Right, hello world on Linux, right. Problems with hello world. Okay, so we're off to a great start. People are already discussing some sort of like a problems or something like that. Okay, the only thing I care is just like a simple example of hello world that just works and I can figure out everything myself. Okay, Phasm demonstration of writing simple ELF executable. So you have to actually declare that this is the ELF format. So then you define segment readable executable, entry start, segment readable, writable, but you never actually define. I'm confused about whether it's a segment or section. Okay, compile successfully while the code example. Okay, so we can give that thing a try. Right, we can give that thing a try. So this one is going to be, right, so instead of bit 64, we're going to have format elf, executable 3, whatever that's supposed to mean. Then segment breedable. Yeah, breedable segment. Submissive and breedable segment. Anyway, so, and in here we say entry start, and the start is going to be just this, right? So this is the start. Then we perform all of that, and this one is a segment, right? Segment readable, writable. I'm not sure if I want to have a writable, but I'm just going to keep it anyway. And probably that is it. So let's give it a try. I'm going to try to compile it. And we have a legal instruction, right? So process to move syswrite, and it didn't work. What if I replace syswrite with 1? Will it just compile now? Okay, so it does not work at all. Is that because it's... Oh, I think this is because it thinks that it's in a 32-bit, right? So it probably expects something EAX. Okay, I was right. And if I use something like syswrite, yeah, okay, I see. So it's in 32-bit mode. I wonder how can I switch to 64-bit mode? Phasm 64-bit mode, right? Phasm 64-bit flat assembler. And what's interesting is that there's no, like, every time I try to Google something, it redirects to discussions instead of like actual documentation, which rather worrying. Not gonna lie, it's kind of worrying. Like, is this thing even alive? Because people discussed that like 2 years ago. Well, it's, wait a second. 2018 was 4 years ago. Did you guys know? Did you guys know that 2018 was not 2 years ago, but it was actually 4 years ago? Fuck. Ah. Okay. So that is kind of sad. Not gonna lie. 2018 was 4 years ago. So 64 Comrade. How can I have 64 bits? Okay. So what people say? I'm trying segmentation fault, 64-bit. What the fuck is going on in here? So this is not what I was looking for. Let me remove that. Phasm 64, maybe x86 64. Flat assembler docs. 64. Okay, so we have something in here. Oh my god, this is so bad. It's so small, and it takes a lot of time to actually load up. Okay. Okay, cool. So it does know about them. But it doesn't tell me. It doesn't tell me how to switch to that mode. You can turn on generating the code using with use 64. Can I just do something like this, and will that work? Okay. That is very interesting. So that didn't work. I really like to see an example. Directive use 64. How do I use that thing? Phasm use 64 example. In 32-bit mode. Okay. Really? Is that how we do that? You put it in here? Sure, I can put it in here. I mean, why not? Is it gonna work? Is it gonna work now? Yo. Undefined symbol syswrite. Okay, so at least now it kind of complains about this shit. So can I just get rid of that and do 1? All right, so these macros, none of these macros worked. Okay, so we'll have to deal with that. So this is going to be another one. Sys exit is going to be 60. And okay, so we managed to do something. Cool. I wish these macros worked, but apparently they didn't. And you also have to switch to this weird 64-bit mode. And apparently, what it generated actually, it's a... Wait a freaking second, it says it's a ELF 32-bit LSB executable, and look at the size of that shit. It is ELF. What the fuck? This is awesome. Though I don't like that it's marked as 32-bit like ELF. Maybe we'll have to do some shit, like use ELF executable format and probably ELF64. Can we do something like this instead? We can. Okay. And it's ELF64. And if I use an ELF64 in here, do I need this shit? I don't. Okay, perfect. I found it. I literally guessed it. That's how good documentation of Phasm is. I had to guess what kind of directives you have to use. Good one. Very, very good one. I like it. Me like it. Alright, so, and if I try to run this entire thing, Phasm, right. It's not even executable. So is it really executable? It didn't mark it as executable, which is a shame in my opinion. Right, so we can do something like chmod plus x hello Phasm, right. And if I try to recompile that, there we go, here is the executable and hello Phasm. Holy fucking shit! 235 bytes ELF executable working! What the hell? Holy shit! I like this. So maybe we can use this shit. That is very poke. The fuck? Holy shit. Okay. That is very, very interesting, not gonna lie, so I really like that. I really fucking like that. Let me take a look. But the size increased, probably because the x86-64 instructions are longer, but I know nothing about encoding of x86-64 instructions, it's just my guess. They could be a bit longer. Right, so... Okay, good. Okay, so I wanna basically take this thing, right? In all of the Porth executables, we always include this print function, right? That we basically wrote originally in C code, compiled down to assembly, and basically hard-coded within the compiler. Right. This is a piece of code that was originally written in C, the source code of which is completely lost to history. You could probably find me writing the source code for this sequence of instructions in the old archive of videos about Porth, but I removed that source code since then. So, yeah, I just copy-paste this thing around, and it's quite convenient because it allows you to print numbers. You put a number into rex, right? And it just prints that to the standard output with a new line, right? And it's quite useful for debugging. So what I want to do, I want to try to port this entire thing to Phasm. If I put it in here, is it going to compile afterwards? So that's an interesting question, because that checks quite a few things about the syntax of Phasm, right? So let's give it a try. Excuse me. Oh, right. Did it just freaking compile? So it's like they're really compatible with each other, apparently. Alright, so and if I try to run hello Phasm, it says hello world. But now I'm gonna do the following thing. I'm gonna move 69 into rex and I'm gonna call print. Will that print a 69 after hello world using these instructions that we generated from a C code, the source code of which is lost to history? How about that? That's a mystery. It didn't. Fuck. Well, it printed number, but it didn't print the number I would expect it to print. I expected it to print 69, but it printed 1. The question is why? Maybe because I don't have to put it into racks, I have to actually put it into RDI. I forgot that I'm following the x86-64 Linux call conventions, and according to these conventions, I think RDI is the first argument. I think it is. So if I try to recompile that, 69, baby! Nice. Nice. So yeah, I just copy-pasted the instructions, and they work, which leads me to believe that the entire thing is going to be as simple as just copy-pasting, right? But changing the header and footer, if you know what I'm talking about, right? So here we have this, like, even data works, right? Even, like, they are compatible with each other. So the only thing we have to change in here is just, like, yeah, the header and footer and whatnot. I'm really glad. So let's go ahead and do that, I suppose. Okay, so first in Porth, I would like to maybe introduce some sort of a flag that indicates that you want to use Phasm instead of Nazm. Right, so let me see how we're going to approach all of that. So if I take a look at the usage, right, so where is the proc usage? Where's the proc usage? So here we print how you're supposed to use this entire thing, right? So here is the compilation, and here is a bunch of flags. Okay, so maybe I'm gonna just introduce like a quick flag called Phasm, right? And it's gonna be basically use Phasm instead of Nazm, whatever that's supposed to mean. Right, and this is basically fd at 64 f puts. Cool. So, and where do we handle -r? Right, so here is the loop that handles all of that. So if we can encounter r, we set one thing, and so on and so forth. Okay, so if among the arguments we are encountering Phasm, right, we encounter Phasm, what we have to do, we have to probably set Phasm to true and continue looping through the arguments. If I try to compile this entire thing, I'm pretty sure it's not going to compile because I need to define the Phasm variable. Compile porth.porth. What do we have in here? Unknown variable Phasm. Let's define that variable somewhere up there. So it's going to be something like memory Phasm size of boolean, right? Size of boolean. And we're going to initialize it with false. There we go. So after that, it is going to work. It is going to twerk. All right. Alrighty. So what do we have? I think in the compilation mode, right? So if I do compile and we have Phasm. Generate Nazm, the output file path, okay, so that's fine. If Phasm, oh shit, this one is actually very interesting. So this entire thing has to be under Phasm, which is fine, I guess. Right, if Phasm, read it as Boolean and not Phasm, we're gonna use the Nazm. This is how, by the way, you call the external programs in Porth, right? So here is the sequence of arguments, and then you do cmd echoed, and that performs the external command. 1, 2, there we go. So, and this is Phasm, and if it's not Phasm, right, so in here, we're gonna do, if it is Phasm. You know what, I think it's gonna be, yeah, it's fine. So let's do here, eputs to do Phasm generation, though let's actually start it like this. Right, so this is going to be output asm, and then we'll have to call it. And I really like that you don't have to use the linker for Phasm. CQ undefined. Thank you so much for 100 bits. Thank you. if you Google Phasm mod, there is a GitHub project with syntax highlighting for Emacs. Oh, okay, thank you. So Phasm mode. Let me see. Oh, okay. Okay, thank you so much. Right. So unfortunately, it is not the first link, but it is there. Thank you. Okay. Does it have auto load? It does seem. Yeah, I saw auto load somewhere here. So add to. Yeah. All right. So I'll have to add it to the like a list of things that automatically enable that mode. Okay, I'm gonna take a look at the row and. Let me go to Emacs local, right, and I'm gonna just download the entire thing. So Phasm mod. Porth mode. And another thing we can do Phasm mode, right. Let's just add Emacs. So, and if I go into the hello Phasm, and Phasm mode. Okay, thank you very much. This is actually very useful. The reason why it's useful is because it highlights the keywords, which is a good indication if I'm doing something wrong or something right. Thank you so much. I'm gonna give this thing a star, of course. So this is my star to this entire stuff. Right, here is the star. And here is this thing, and I'm also gonna give it, put that in the description. Okay. So I'm gonna put it somewhere here. Phasm mode for Emacs. Thank you so much. Second star, yes. I really hate how GitHub actually moved starred to the right. It used to be somewhere here, and I kind of like, because of that, I want to like click on fork, but I don't want to fork anything. Thank you very much. Like, why? People already confuse fork and starred a lot, and they just make it even more confused. 120 and you get to rescue princess. Haha! That's a pretty nice achievement. Okay. Random people from 7 years ago are always so useful. Yeah, exactly. Alrighty. So what I wanted to do, I forgot. Yeah, I wanted to test my shit, right? So if I compile port.porth, right, there we go. Okay, so it seems to be compiling, it seems to be working, it seems to be twerking. Nasm is unbearable. So I hope Phasm is going to be faster. I really hope so. Though it's generating less code. So if it's generating less code, maybe it's doing less. Which is not true, by the way. For instance, if you have optimized a compiler and it's optimizing the size, it's generating less, but it's doing more. So it's not a good criteria. But I'm hoping, right? So Phasm is not supposed to be optimizing, hopefully. I don't know. All right. So, and here I want to actually move this entire thing. So I'm supposed to be doing it like so. So mv move output executable to porth, right? So this is what we're going to be doing. Okay, so, and now if I try to do something like Phasm, right, if I try to do something like Phasm, it should eventually tell me that Phasm is not implemented. Okay, it said generating Phasm, but it never actually did anything, which is really weird. Excuse me, so I think I fucked up somewhere. So let's actually find out. Let's actually find out Phasm. Right, so we're reading Phasm, and if it's not Phasm, I'm saying generating... Oh yeah, I should have done this. Okay, I already see where I made a mistake. So, and next thing I need to do, I need to call Phasm, right? If I take a look at hello makefile, the only thing I have to do in here is just like Phasm, hello Phasm, right? So Phasm, hello Phasm, but do I need to provide like -o? It would be kind of nice, I think. But maybe not. Okay, so let's just keep it as Phasm, and then I'm providing output asm, and hopefully it will generate the executable, right? It will generate the right executable. Cool. So Okay. So first we need to do this thing first. And then I'm gonna do Phasm, and it should fail after some time, after we generated everything, right? So, okay, generate Phasm Linux x8664 is not implemented. So the way I'm gonna do that, I think I'm gonna just literally copy paste everything in here, right? Literally copy paste the entire thing. I might as well actually search for end in here, right? And go back to proc. So begin proc. So this is gas, this is Phasm. Okay, and then I'm gonna remove this entire thing. And the way we're gonna do that, so I'm gonna try to just run the entire thing. Right, I'm gonna just try to... I have an idea actually. I can do compile and run this thing simultaneously, right? Compile and run this thing simultaneously, which I will try to compile with the flag Phasm, and I'm going to try to compile it itself yet again. So this is what you can do with our compiler, right? I'm compiling the compiler, then running the compiler and try to compile it again, but with the Phasm flag. So here I'm compiling it with Nazm, but on the second run I'm trying to do that with Phasm. And it is possible, right? I'm not even joking. It does allow you to do that. So here is the first Nazm generation, right? It will take some time, right? After that, it tries to run it again, but with Phasm. And yeah, Phasm failed. As you can see, Phasm failed because it doesn't know what is a bit 64, right? So, and now we just need to adapt the header as we did in the pure assembly, right? So this is going to be hello, Phasm, and so we know instead of bit 64, we have to do format elf 64 or something like executable 3. So that's the thing we're doing in here. Am I doing the right? Yeah, it is Phasm. So for the segment, we just have to say segment, you know, submissive and readable. Segment. Readable, executable. All right. So in here we have a print. Right, print. We don't have to do anything with the print. So instead of global start, we have to say entry start. Right, entry start. And here we just have the start, right? So this is just the start. This is just the start. Entry start. And after that, I don't think anything else is needed except for the data, right? So this is the segment data, and in here we have readable and writable. All right, so here's the readable and writable. And I guess that's it, right? So because we do like a minimum thing. Okay, this one is interesting because this is a segment BSS. I'm not sure if it's gonna work, but we're gonna give it a try, right? We're gonna give it a try just to see if it's gonna, you know, work properly. Okay, so everything type checked, which is nice, and now we're generating the actual code. We're gonna be running it again. So then we're running Phasm. Okay, it complained about segment BSS, right? It doesn't know segment BSS. Phasm segment BSS. How do you do that? Phasm for... Okay, so maybe I have to do Linux. So I still haven't figured out the things. Interpreter readable, writable, segment text, data, Phasm, not equal Nazm, or Mazm, or Gazm, or Gazm. Nice one. All right, I'm sorry, I'm 13. Okay. All right. So I don't quite understand. Right. So you can do sections and you can do other things. All right, so I think we need to go back to the drawing board. GNU assembly is gas, as far as I know, right? So it's supposed to be gas. So I didn't know there's such thing as GASM, but I'm not laughing at something that doesn't exist. I'm saying that it's a funny combination of two words, right? Two words, or, and GASM is funny, haha funny, because if you remove space and reformat it, it's haha funny sex word. This is what I'm laughing at. Right, I'm not laughing at whether it exists or not. It doesn't matter whether it exists or not. It's like a funny haha sex word. Okay, so anyway, we need to go back to the drawing board. Hello, Phasm. Okay. I wonder if I can do section.text, right? Section.text, and just say make, right? So, and it doesn't like section text is not a thing, right? So what if I do something like this? No, you have to use the segments. Segment readable or writable. Okay, so Phasm segments. Maybe we can find documentation on segments. Segments and sections flat assembler. I was hoping for documentation, please. Okay, programmer specifies sections that produce an O file which can be linked in. Programmer specifies segments and can also specify an assembly file that is to be executable, and Phasm directly creates an executable file with the .o file. So Phasm, I want to go to the documentation. Let's find documentation of our nation. Okay, so this is the programmers. To flat assembly G, I don't really care about some G. I care about the flat assembler. It has a Windows programming, but it doesn't have a Linux programming, but maybe we don't care, right? So segments. Segment. Segments. To specify a segment. So there is a segment registers. Segment prefix. I don't feel like there's anything particularly useful in here. Understanding the flat assembler. That's really interesting. Like, why is that a separate thing? Okay, Windows programming. What about the segment? It never actually says anything. This is really, really bad. Okay, so maybe we have to read the... My internet just went down, apparently. Okay. Okay, if you're talking about compiling executable elf file in Windows after segment directive, only some flags can be set. Here is a quote from Phasm manual. And instead of section, there should be segmented. It sounds like a quote from Bible or something. Look at that. And instead of sections shall be the segment directive used, followed by one or more segment permission flags, and optionally a marker of a special elf executable segment which can be interpreter, dynamic, or node. The origin of segment is aligned to page 4 kilobytes, and available permissions flags are readable, breathable, writable, executable. For example, valid definitions are readable, writable, executable, interpreter readable, and readable, writable. I can try to presume that BSS is interpreter readable, because BSS is automatically zeroed out and it doesn't take any space, right? Okay, so let's say that there is a Linux no code segment or data segment and no section code and data, right? Code and data are not sections that the OS knows or cares about. You as a programmer decide code by making the section executable and data by making it readable, writable, or if you want something else, just compile the flags as needed. Okay, so section is a segment, depends on your target output. So in Windows, all right. So I'm really interested about interpreter. Though I can just try to do something. Right, so this is going to be segment, segment, readable. Right, and in here I can define something like test. Not really test, but some sort of date. Dumb. And res b just allocate 69 bytes. Right, so reserve 69 bytes. And if I try to compile the entire thing, illegal instruction res b. Okay, so that is very, very interesting. There is a resq. I know that there is a resq, but there is no res b. So as far as I know, just like you reserve a certain amount of bytes. Phasm reserve data. RB. Oh, it's actually called RB. Yeah, okay. So that makes sense. We can call it RB then. So instead of resb, it's called RB. Makes sense. Cool. So we reserved a certain amount of data. And here is an interesting question. If I like keep increasing this entire thing, is it going to be part of the executable? It is not. Is it? Right. That is cool. So I can actually make it as huge as I want, maybe a million, right? And it's gonna be 1 megabyte, right? So is it recompiling? Okay, and it's still very small, right? And then if I do hello Phasm, it is segmentation fault. I wonder why. Why it is a segmentation fault all of a sudden. That's really weird. Okay, so like minus b. And it is in fact a segmentation fault. Right, but if I remove this thing, it is working. But if I put this thing, it is not working. Cool. So example RB, reserve bytes. Section data, import data. Oh, but is that... Okay. Data. So can I just put data in there? Readable data. Okay. Segment data, readable data? No, I cannot do that. So it really... No virus alert. Why are they using sections? Section BSS readable data. Yeah, illegal instruction, you have to use segments. There's so little. We're almost there. I really need the BSS section. I really need BSS section because our entire runtime depends on having that thing. So that is quite important. So yeah, let me actually get rid of everything in here. So maybe just try to remove line 55. Doesn't sound like a bad idea, but I mean, it's not really what I want. It does work, but it also kind of increases the size of the... Or does it? I don't really know. What if I have like 100 of these things? Right, so and if I take a look at the... Okay, that one is really interesting. Look at that. Huh. What if I put it in here? Oh shit, look. And it blow up. It fucking blow up. I see. If you're reserving shit at the end, it actually compresses this entire stuff. This is cool. We can use that. Thank you so much, Bitstream. I would give you VIP, but you already mod, so... yeah. So I wonder, but is it gonna be always 0? That's the question. Is it always 0 though? It might not necessarily be always 0, so that's kind of a problem. We'll give it a try, whatever. So we're gonna just keep that in mind. So Phasm Obviously, I probably don't understand everything when it comes to like sections and stuff like that, but I'm trying. I'm desperately trying. So, okay, so here is the segment, BSS. We probably don't need that, but I'm gonna just comment it out. What do they want from me? Okay, so let's just comment it out. Instead of res q, we need rq. I hope it does exist there. I hope it does exist, so it's gonna be res q. It does exist, okay. rq, rb, rb. All right. Okay. So the time has come to actually test it out. So where's the port? And we're gonna try to run it with Phasm. So we're generating NASM and some other shit. Okay. Out of memory. I wonder who actually said that. Out of memory. That is very interesting. But it tried Phasm out of memory. Out of memory issue. Okay. To work around this. Out of memory. Use Phasm. Okay. So that sounds like a pretty good solution. Ports.porth Phasm. Just, you know, just get more RAM, forehead. Okay. Just get more RAM. Oh, okay, so this is a very interesting thing. And in here, yeah, this has to be a C string. All right. Just get more RAM. Oh. 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 Cool. That didn't work. To allow Phasm to suck. Thank you. That worked out perfectly. So, and what Phasm told us? Set the limit. Ah, wait. What the fuck? Well, okay, sure. I'm really glad, by the way, oh my god, I spent some extra time making sure that my logging of commands actually escaped everything properly. And for like a brief second I thought that it's kind of a useless feature, but it's nice. But this feature of properly escaping shell commands just saved my ass. Because I managed to notice it very quickly. That, yeah, it has to be two separate, but it shows as a single one. Right. So that feature actually saved my ass. That's very cool. That is very freaking cool. I really like that. Alrighty. Right failed. Why? So let me see. Phasm right failed. What a journey. Hello all, I'm a newbie Asm coder and I can't understand what's wrong with this code. Okay. So right failed. Compiler error right failed. Okay. You must have this executable still running somewhere in the background. I see. Because it is trying to replace itself. That makes a lot of sense, in fact. That makes a lot of sense, because I just run the output and it was trying to... Okay, that makes a lot of sense, I see. So move and I'm gonna just move the output to the porth, right? So here it is. And now I can do porth compile, porth.porth, but I'm gonna do that with the Phasm. Right, so hopefully that will do the trick. And it worked. And I would say that Phasm is way faster. Phasm is definitely way faster than Nasm. So it manages to compile the whole thing in less than a second, 162 kilobytes, or milliseconds, I'm sorry, not kilobytes. So Nasm does do a lot of weird shit. So Phasm is way faster. Phasm is way faster. But the question is, does it even work? I don't freaking know. So output Asm is slightly different. So here's the format, and it feels a bit bigger for whatever reason. I wonder why. Why does it feel bigger? Even though it's pretty much the same, but yeah. So, and the size of the executable. Look at the size of the executable, 200 kilobytes, right, essentially. The one that is compiled with Nasm is 686 kilobytes, so this one is smaller. But it may not work. It may not work, and the reason why it may not work is because the section with the code, right, with the BSS, may not be zero initialized. I know that whatever you put in BSS and Nasm is zero initialized, but I'm not sure about Phasm, so let's give it a try. I'm gonna try to run the output. Oh, you have to also make it executable, of course. And let's do output. And it worked. This shit worked. It just fucking worked. So yeah, we compiled porth with a different assembler. Right, we recompiled porth with a different assembler, and it was faster. It was faster, and the resulting executable is way smaller. That is so fucking cool. I didn't expect such an outcome. Okay, so let's actually try to do something more complicated, right? So I'm gonna go ahead and just like move the output into the porth, right? So we're gonna do it like that. So that way I can try to recompile the porth with itself, all right? So let me give it a try. Porth, I'm gonna compile it into Phasm, of course, and I'm gonna try to compile it with itself. Okay. Phasm porth just recompiled itself. It can compile porth. So, and of course, after that, one of the things we can do, we can move output into porth back, output into porth, right, and try to compile it again. And yet again, so the bottleneck of the compilation process was Nasm. We replaced the assembler, and now the bottleneck again is the process of generating, right? So, and oh yeah, here's the thing. Let me actually try to do this thing. So after we compile this entire thing, I think we have to do chmod, right? tmp end Phasm. Can I actually instruct Phasm to make an executable? Dump symbolic information, define symbolic maximum allowed number of passes. Okay, whatever. So I'm gonna do the following thing. So first I'm gonna save this thing, chmod tmp append pointer, then plus x, and then so all of that has to be C, by the way. I mean, the compiler will catch that anyway, because there is a huge difference between the porth strings and C strings. Porth strings actually put 2 values on the stack, C strings only put 1, so the compilation will just fail if I try to use the porth strings, so it's not that big of a deal. Right. And then cmd echoed. There we go. So now let me try the following thing. So where is the porth? Okay. One more time. All right, and it just it renamed it, but it didn't do that because it was using still the old version, so we have to do that again. So it was just using old versions that didn't actually change anything. Access U is okay. Output Asm. So we'll have to do that again. Okay, so that's fine. That's fine. Trust me. Okay, +1. It probably will fail yet again. It failed yet again, which we'll have to do that one more time and one more time. Last time, hopefully, should work. Yeah, it's kind of difficult to work with a self-hosted thing, right? Because if you screw up, you may screw up your entire like bootstrapping chain. But now everything's fine. And as you can see, we do chmod, so we can. It still doesn't do that. Why? Why doesn't do that shit? Excuse me. Oh, I'm an idiot. I think I'm already tired. Yeah, I'm already tired and I'm starting to make very stupid mistakes at this point. So yeah, you get the point, right? You get the point. So we have this thing and it's surprisingly working. So let me do the following stuff. Right. So I'm gonna try to do that stuff and recompile it. All right, so and one more time. So now we can try to run on different tests and stuff like that, right? And now it can keep compiling itself, so we can actually make it recompile itself constantly. Yeah. Yeah. So it's a little bit slower because, as I already said, we have a lot of unoptimized things, but we can make it a little bit faster if we disable the type checking, right? So without the type checking, it's a little bit faster. So the port is quickly recompiling itself. Cool. I really like that. So I also not really sure that I want to have a Phasm flag. I would rather prefer to have something like -t flag, which indicates sort of like the target, right? And with the target, we're going to have something like NASM Linux x8664, then Phasm Linux x8664, then Gas Linux x8664, right, not fast, gas, and then maybe things like NASM Windows x8664 and so on and so forth, right? So, and then we're gonna have a bunch of targets and we'll make it super easy to add more targets for generation, right? So yeah, but in the future I actually plan to have no dependency of any on any of the external assemblies, right? Maybe in the future we're gonna have something like I don't know, Phasm. Does it sound cool? Sounds interesting? We're gonna have that. Yeah. Maybe things like, I don't know, Linux, Gas, Linux, MIPS also. So CQ Undefined asks, thank you so much for 100 bits. When are you going to allow contributions? Roughly when I completely get rid of the Python, right? So it is very important for me to get rid of the Python first before I allow contributions, because Python will just attract a lot of low quality contributions, because a lot of people will not want to mess with the port itself, and they will go for something super easy within the script that is going to be removed anyway. And because a lot of people is going to modify and contribute to the script, it's kind of weird that I'm going to just straight up nuke that script, right? So yeah, essentially first I'm going to completely get rid of from the Python. There will be zero Python in the source code, and then I'm going to open the contributions, and contributions are only going to be allowed within the port. So that's basically the idea. Right now I cannot get rid of Python yet, so there is a couple of things that needs to be done first. Specifically, we need to rewrite test.py in port itself. It's quite important. Right, and also there is a couple of to-dos within the port that needs to be fixed. So, and after that I will open the contributions. So I guess there's no point in looking into other assemblies for now. Phasm works just fine, right? I'm not going to remove NASM support, right? NASM is going to be there, but I'll probably change the default generation into Phasm, right? So because it's faster and it's just like a little better, also generates a small executable and stuff like that. So, yesu, kawaii freaking desu. Okay, so I want to probably add a couple of to-dos in here. Right, so minus Phasm. Where is my minus Phasm flag? Okay, so it's gonna be to do. Introduce minus T target flag instead of Phasm flag. Oh, right. And so what we're gonna do in here is basically I'm gonna say porth introduce minus Phasm flag. There we go. And I'm gonna push that right into the repo. So I'm not sure if anyone wants to play with the hello world in Phasm. Does anyone need a hello world in Phasm for Linux or something like that? Maybe, I don't know, because yeah, I'll see if I want to upload it anywhere. Anyway, I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next Zozin session. And let's, I guess, rate somebody. We haven't rated anyone for quite some time. So is anyone doing anything super epic on the software and game development section of Twitch? So, who do we have in here? Supinic is probably doing some software some runescaping. I'm not sure. So, Bold Engineer, by the way, is he doing like assembly? Soldering, to be fair, sounds like something that we probably should raid after the assembly, like soldering and stuff like that. It does make sense. I only wish the Twitch was a little bit faster. So let's actually raid Bold. Not bad, Bold Engineer. There we go. Alright, get ready for the raid, boys and girls, and I see you all next time. Love you all.